Welcome to the Huberman Lab podcast, where we discuss science and science-based tools for everyday life. I'm Andrew Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. Today we are discussing microplastics. Microplastics are an extremely interesting and important topic that everyone should know about. And the reason is microplastics are indeed everywhere. They are in the air. They are in beverages we consume. They are lining the inside of soup cans. They are lining the inside of paper cups made to hold hot water, coffee, and tea. And there are a lot of animal data, and indeed some human data, showing that microplastics, which consist of particles of different sizes, can be very detrimental to our health. At the same time, it's important to realize that as of now, we don't have any causal data linking microplastics to specific human diseases. That said, there's a lot of correlative data, and today we are going to review those correlative data, and most importantly, we are going to discuss the various things that we can each and all do to limit our exposure to microplastics, or at least to facilitate the removal of microplastics from our body. Because, as we'll soon discuss, you have microplastics in essentially every organ and tissue of your body right now. And you are constantly being bombarded with microplastics. So the challenge for me, and indeed for you as well, is to frame this topic of microplastics accurately. It's important that we understand they are out there, they are in us, and indeed, they can cause serious issues for our health. However, we also need to take agency. We need to understand how we can limit what's called the bioaccumulation of microplastics in our organs and tissues. And I don't want to be alarmist. Today's episode is not about getting you to be petrified or about developing some sort of hypochondriasis about microplastics. It's designed to inform you about what they are, where they exist in particularly high amounts, and the things that you can do to limit their impact on your biology. Because I think it's fair to say that we are not going to rid the earth of microplastics. They are just too pervasive. Now, the one caveat is that there are certain populations of people, in particular people that are pregnant or people that have young children and those young children themselves, that should really strive to limit their exposure to microplastics. So by the end of today's episode, you can be confident that you'll understand a lot about what microplastics are, the impact that they are currently having, some of the potential impact that people are starting to investigate, and ways that you can limit their negative impact on your brain and bodily health. Before we begin, I'd like to emphasize that this podcast is separate from my teaching and research roles at Stanford. It is, however, part of my desire and effort to bring zero cost to consumer information about science and science-related tools to the general public. In keeping with that theme, I'd like to thank the sponsors of today's podcast. Our first sponsor is LMNT. LMNT is an electrolyte drink that has everything you need and nothing you don't. That means the electrolytes, sodium, magnesium, and potassium, in the correct ratios, but no sugar. Now, I and others on the podcast have talked a lot about the critical importance of hydration for proper brain and bodily function. Research shows that even a slight degree of dehydration can really diminish cognitive and physical performance. It's also important that you get adequate electrolytes in order for your body and brain to function at their best. The electrolytes, sodium, magnesium, and potassium, are critical for the functioning of all the cells in your body, especially your neurons or nerve cells. To make sure that I'm getting proper amounts of hydration and electrolytes, I dissolve one packet of LMNT in about 16 to 32 ounces of water when I wake up in the morning, and I drink that basically first thing in the morning. I also drink LMNT dissolved in water during any kind of physical exercise I'm doing, especially on hot days if I'm sweating a lot and losing water and electrolytes. LMNT has a lot of different great tasting flavors of LMNT. My favorite is the watermelon, although I also confess I like the raspberry and the citrus. Basically, I like all the flavors of LMNT. If you'd like to try LMNT, you can go to drinklmnt.com/Huberman, spelled drinklmnt.com/Huberman, to claim a free LMNT sample pack with the purchase of any LMNT drink mix. Again, that's drinklmnt.com/Huberman to claim a free sample pack. Today's episode is also brought to us by BetterHelp. BetterHelp offers professional therapy with a licensed therapist carried out entirely online. Now, I've been doing weekly therapy for well over 30 years. Initially, I didn't have a choice. It was a condition of being allowed to stay in high school. But pretty soon I realized that therapy is an extremely important component to overall health. In fact, I consider doing regular therapy just as important as getting regular exercise, including cardiovascular exercise and resistance training exercise, which of course I also do every week. Now, there are essentially three things that great therapy provides. First, it provides a good rapport with somebody that you can really trust and talk to about any and all issues that concern you. Second of all, great therapy provides support in the form of emotional support, but also directed guidance, the do's and the not to do's. And third, expert therapy can help you arrive at useful insights that you would not have arrived at otherwise. Insights that allow you to do better, not just in your emotional life, in your relationship life, but also the relationship to yourself and your professional life and all sorts of career goals. With BetterHelp, they make it very easy to find an expert therapist with whom you can really resonate with and provide you with these three benefits that I described. If you'd like to try BetterHelp, go to betterhelp.com/Huberman to get 10% off your first month. Again, that's betterhelp.com/Huberman. Okay, let's talk about microplastics. What are microplastics? Microplastics, as the name suggests, are little itty bitty bits of plastic. How itty bitty? Well, microplastics range in size from 1 micron, which is 1/1000th of a millimeter, all the way up to 5 millimeters in diameter. Okay, so anything in that size range is considered a microplastic. Anything smaller than that, so anything smaller than 1 micron in diameter, 1/1000th of a millimeter in diameter, is considered a nanoplastic. And indeed, there are lots of microplastics floating around in the air. There are lots of nanoplastics floating around in the air. There's lots of both of those things in the ocean. There are a lot of those things in food, especially packaged food. There are a lot of those things lining cups. There are a lot of those things in everything that we consume, essentially. So what does it mean to have all these microplastics and nanoplastics floating around in our environment and going into our body through fluids and foods, etc.? Well, there is some serious concern because these microplastics potentially can disrupt cellular health, organ health, and could potentially lead to certain forms of disease. We'll talk about the ways they could potentially do that. However, I want to also emphasize that your body is incredibly good at dealing with foreign invaders. It's very good at getting rid of stuff that isn't good for it. However, microplastics and nanoplastics have been shown to lodge within specific tissues and stay there for long periods of time. So you'll notice during today's episode, I'm going to go back and forth between the stuff that's really scary and then reassuring you that we're not sure whether or not we need to be that scared about these microplastics and nanoplastics yet. Okay, what I want to do is give you the evidence so you can decide how much effort you put into limiting your exposure to these microplastics and nanoplastics and how much effort you put into trying to rid your body of them. Okay, I'm not here to paint the picture one way or the other because frankly, the data just don't line up with one argument or the other, that they're extremely dangerous or that they're nothing to worry about. Let me give you an example of something that you might have heard in the media and on recent podcasts out there that's very scary. The argument, based on what seemed to be a pretty high quality publication that you may have heard, is that every single week, we ingest up to a credit card's worth of microplastics and nanoplastics. Okay, you might have seen that in headlines and in other podcasts. And indeed, there was a paper arguing that. However, a more recent paper looked at the quantitative analysis they used a different quantitative analysis, and claimed that they vastly overestimated the amount of plastic that we ingest every week. What do I mean by vastly overestimated? This newer analysis of the same data claims that the credit card's worth of plastic that it was argued we consume every week, well, that was an overestimate by a millionfold. And in fact, it would take 23,000 years to consume enough plastic to lead to that credit card's worth of plastic in our bodies. Okay, so now we have very discrepant data, or rather we have very discrepant analyses of the same data. So you're starting to get a picture of just how confusing this whole field is. But we're going to parse it a little bit further by saying that it's also very clear that microplastics and nanoplastics are everywhere. Okay, they're just everywhere you look. In fact, if I were a PhD advisor for somebody in toxicology or a PhD advisor for somebody in environmental science, and they needed to have a surefire publication, I'd probably suggest that they work on microplastics and go out there and try and find yet another source of microplastics and use a better analysis, for instance. Okay, doing a graduate thesis isn't just about getting a publication, but what I'm trying to refer to here is that wherever people look for microplastics, they find them. This is true in our environment, and this is true in food, this is true in water, and this is also true for our tissues. So in the last couple of years, there's been an explosion in the number of scientific studies exploring which tissues of the human body, so not just animal models, but the human body, contain microplastics and nanoplastics. Okay, so by examining postmortem tissues, that is tissues from people who are deceased, it's been discovered that there are microplastics and nanoplastics lodged in the brain. So if you take the brain of a deceased adult human, what you find is that they have about 0.5% of the total weight of the brain from microplastics. So this is about a teaspoon of salt or sugar's worth of microplastics. Might not seem like much, but if you think about how little neurons are, a typical neuron will have a cell body. This is the area that contains the nucleus with all the DNA and so forth. That cell bodies of neurons vary in size tremendously. They can be as small as 5 to 8 microns across, to as much as, I've seen some neurons down the microscope that are 50 microns. I've seen some that are 100 microns across. It depends where you look in the nervous system. Okay, so if you start to think about a half teaspoon of powder of microplastics and nanoplastics, that's a lot of microplastics and nanoplastics that could be distributed in lots of different places in the brain. And a little bit later, we'll talk about what the potential impact is of these microplastics and nanoplastics on the function of particular types of neurons that may impact things like neurodevelopmental trajectories. Okay, the argument has been made. I'm not making this argument, but the argument has been made that microplastics and nanoplastics may correlate with things like autism, may correlate with things like attention deficit hyperactivity disorder. I don't actually believe that the data there are strong enough to make those arguments at all. However, I will tell you that the presence of microplastics and nanoplastics in the brains, that is postmortem tissue, okay, so deceased people taking the brain, chopping up the brain, looking at it down the microscope and seeing microplastics, and then quantifying the amount of microplastics in different compartments of the brain and distributed across the brain. That is concerning to me in the sense that there's enough of it in there, and the function of neurons in the nervous system is precise enough that you could imagine, given that these microplastics and nanoplastics are lodged in particular categories of neurons that do in fact impact things like reward and motivation, things like movement, etc., that they could be impacting the function of the nervous system. But there's no direct causal relationship, at least not in humans. There's some interesting data in animal models. We'll get back to that a little bit later. So there's microplastics and nanoplastics in brain. You'll find microplastics and nanoplastics in other tissues that have a blood organ barrier. What do I mean by that? Well, the brain is encapsulated in the so-called BBB, the blood-brain barrier. And that's because your brain tissue, because it doesn't turn over across the lifespan, you don't produce many new neurons. There are a few places you produce new neurons, like the olfactory bulb, the dentate gyrus of the hippocampus, a few places, but these are far and few between. Most of your brain tissue that you're born with is the brain tissue that you're going to die with, provided you don't lose that brain tissue through the course of your lifespan through a head injury or something like that. The neurons you have when you are born actually are far more numerous than the neurons you have at the time when you die. This is important, and it's one of the reasons we have a blood-brain barrier. Nature is very smart. It designed a barrier so that molecules that might be dangerous to the brain can't enter the brain, and that's what the BBB is for. Microplastics and nanoplastics are making it from the bloodstream into the brain. Okay, this is what I mean when I say they can cross the blood-brain barrier. Then if we take a step back and we ask ourselves, what are some other tissues in the body that have a very robust barrier from the blood? Because a lot of things get into the blood, and that's not necessarily good, but it's not necessarily bad if you can excrete those things, right? We have a lot of detoxification mechanisms that include our liver detoxification, etc. But if these particles are getting from the blood into the brain, what are some other tissues that they're getting into that have these thick barriers or these very stringent barriers? As you can imagine, two other tissues that have very stringent blood to organ barriers are the blood testicular barrier. Why would that be? Okay, why would you protect brain? Well, it can't renew. You don't want those neurons to get contaminated with things, so you put a BBB in, a blood-brain barrier. You also put a blood testicular barrier in males. Why? Well, that's where the DNA are. That's where the so-called germ cells are. So you don't want things getting into the testicle and mutating the DNA there, because then those mutated DNA could be passed on to offspring. Guess what? Microplastics and nanoplastics can cross the blood testicular barrier. And in fact, there was a lot of press this last year about microplastics and nanoplastics being present in every human testicle that was analyzed from postmortem tissue. Likewise, there's a blood follicle barrier in females. Okay, this is where the eggs come from. And microplastics and nanoplastics can cross the blood follicular barrier. So this is why people are starting to get concerned, right? I suppose we shouldn't be so surprised that we're inhaling microplastics, given that they are everywhere. I should mention that there wasn't much plastic around or in use prior to the 1950s. If any of you have ever seen the movie The Graduate with Dustin Hoffman, this is the only time you'll see somebody driving eastward across the Bay Bridge, all right, from San Francisco toward Berkeley on the top deck. It actually runs in the other direction. They shut down the Bay Bridge. That's in The Graduate. And the other thing that's in The Graduate is this famous scene, if you're old enough like me to remember the movie The Graduate. Dustin Hoffman's lying in the pool. It's after his graduation. He's lying in the pool. He doesn't really know what he's going to do with his life. And this guy comes up to him and he says, the future is plastics. And it became this kind of famous line or pseudo-famous line. Now, that movie takes place at a time when plastics were really booming as an industry. And indeed, polyethylene, polyurethane, these plastic materials were developed because they were very durable. They were long-lasting. In fact, they are not biodegradable. They're not broken down very easily, if at all, and certainly not within biological tissues. These plastics went from essentially non-existent in the 1940s and prior to in pretty much everything involved in manufacturing, okay? Even in different aspects of surgical implants and things of that sort. So plastics are indeed everywhere, and that started in the 1950s, hence that line from The Graduate. So it's not surprising that microplastics and nanoplastics would get into our body, right? If they're everywhere in our environment and we're inhaling them all day, then of course they'll get into our lungs, and then they're small enough they can get into our bloodstream. But as I mentioned, the body has these cleansing systems or these detoxification systems to remove things, but they're not removing the microplastics, or at least not all of them, from brain, testicle, and follicle. And I should point out that microplastics and nanoplastics are also found in all the other tissues of the body. In fact, I don't think there's a single investigation of human tissue or animal tissue for microplastics or nanoplastics where they didn't get a positive result, meaning where they didn't find them in the tissue. You can find them in not just the upper lungs, but in the lower lungs. So they're getting deposited in the lower lungs. You can find them in the bloodstream from a blood draw. You can find them in human placenta. And you can find them in what's called the meconium, which is the first stool that a baby takes. This is typically taken within the stool is taken. It's taken by the doctor. It's actually analyzed for various things. It contains bile and a bunch of other things. It's actually an important indicator of the health of the child. It turns out that this first stool that happens in the first 24 hours or so after birth, when that's been analyzed for microplastics, there too you find microplastics and nanoplastics. And that's really got people concerned, because what this means is that microplastics and nanoplastics that mothers are ingesting or that they somehow have lodged in their bodies are making their way to the fetus. Now, you could say, well, is it really a problem? Well, a few years ago, it was at least concerning enough that BPAs, and we'll talk more about BPAs, bisphenol-A, which is a component of microplastics. This is a known endocrine disruptor. It disrupts certain estrogen-like pathways. We'll get into this in a few minutes. Bisphenol-A and BPAs were banned from sippy cups in kids and from any food containers for young kids. So the FDA in the United States, and there are European countries as well, had enough data on this or enough concern about this to say, listen, we are going to make it illegal to have BPA-lined sippy cups or food containers for young kids, in part because the BPA is correlated with microplastics and nanoplastics. So what I'm saying here is that the government has taken pretty avid measures to restrict the amount of BPA exposure through microplastics and nanoplastics to young kids, and yet the fetus clearly is being exposed to microplastics and nanoplastics. This is why at the beginning I mentioned if you are pregnant or if you have young kids or if you are a young kid, you want to go out of your way to limit your exposure to these microplastics and nanoplastics. But if you're an older adult, you probably want to do the same, and we'll talk about ways that you can do that. So I could go on and on about the various tissues besides placenta, in your bloodstream, brain, testes, follicle, lower lungs. You can find nanoplastics in the liver. You can find microplastics and nanoplastics in pretty much every tissue that you look for them. The real question is, how detrimental are these microplastics and nanoplastics? And then, of course, we can talk about where they're coming from specifically in ways that you can control and limit. And when I say control and limit, what we're really talking about here is, yes, trying to limit your exposure to these things. If I were to rattle off the different sources of microplastics and nanoplastics, you would go wide-eyed, and you would probably also just say, okay, I surrender. They're truly everywhere. In fact, I'll do that. Okay, I can't help but do that. But keep in mind, you do have some control in terms of the end result of these microplastics and nanoplastics on your health. So here I go. Plastic bags, storage containers, bottle caps, rope gear, strapping, utensils, cups, floats, coolers, containers, rope, fishing nets, textiles. Sorry, I'm not laughing because it's funny. I'm laughing because it's just pretty much everywhere. Latex paint, coatings, medical devices, automotive parts, tires on the road, degrading, giving off little microplastics into the air, microplastics raining down from the sky, literally. Pipe, film containers, laminated safety glass, car windshields. Oh, great. Even the car windshield. Drinking bottles, textile fibers, resins, paints, varnish, construction, automotive parts. Okay, so basically everywhere, right? These things are everywhere. So what are we to do? Well, what we are to do is to limit the long-term accumulation of microplastics and nanoplastics in our system. There are ways that we can limit their introduction to our system, but as long as you're breathing, as long as you're walking around, as long as you're near a road, you are exposed to microplastics. So until there's a huge movement to make better tires that don't degrade as quickly, or to create filters in our home environments that remove the microplastics, which frankly, I think both of those things are not reasonable expectations, at least not in this lifetime. Well, until then, what you can do is you can try and limit their entry and accumulation into your body. So rather than list off all the ways that you can limit so-called bioaccumulation of microplastics and nanoplastics at the beginning or at the end of today's episode, I'm going to intersperse them at times that are relevant to what I just discussed about how microplastics get into our system and the tissues they are lodged in. So I'll tell you right now that a few ways that you can really do yourself a service in limiting your exposure to microplastics is to limit your consumption of water from plastic bottles. Okay, that might seem kind of obvious, but check out these data. This is pretty wild. There was an analysis of the number of microplastic and nanoplastic particles in bottled water, and it was estimated that there were about 30,000 of these particles per liter of water. Okay, and those data stood for quite a long time. Then imaging techniques for measuring the number of these different particles, in particular the really small nanoparticles, the ones that are less than 1 micron in diameter, the imaging tools for those improved. Okay, and I'll explain a little bit about that in a moment. And there was a paper published in the Proceedings of the National Academy of Sciences in 2024 that showed that the amount of nanoplastic in particular, but microplastic and nanoplastics that are present in bottled water was actually vastly underestimated in that previous study. Rather than 30,000 particles per liter, the reanalysis with better methods showed that it was anywhere from 110 all the way up to 400,000 particles per liter. And the average was 240,000 particles per liter. So that means that the amount of microplastics and nanoplastics in bottled water is actually much, much higher than we initially thought. And a very simple way to limit your exposure to microplastics and nanoplastics is to avoid drinking water from plastic bottles, in particular plastic bottles that have been heated up. Now you might say, well, I don't heat up my plastic water bottles. Right, but you don't know what happened to those plastic water bottles en route to the store you bought them at or en route to your refrigerator, right? They could have sat in the back of a hot truck. They could have sat in the back of a loading dock, any number of different things. Now, this is not to say that if you drink the occasional water out of a plastic bottle that you're going to harm your health. I'm absolutely not saying that. However, it's pretty clear that there's a lot of microplastics and nanoplastics that are completely avoidable, at least avoidable in terms of your ingestion of them, in plastic water bottles. So it makes sense to me why you would want to avoid those. Also, as a consumable that's not very reusable, I suppose you could reuse those plastic bottles, but most people don't. At least they don't use them for very long. They get pretty flimsy pretty quickly. You're much better off having either a stainless steel bottle or some sort of ceramic mug or using glass or using some other vessel for water that is reusable and, of course, that is not made of plastic. And then, of course, the question arises, how much microplastic and nanoplastic is in tap water? And it turns out there's quite a lot of it. Now, it varies according to location, but there are ways that you can get those microplastics and nanoplastics out of your tap water. The best way turns out to be a little bit expensive, admittedly, and that's to use a reverse osmosis filter. So reverse osmosis filters will get rid of all the microplastics and nanoplastics. Of course, it will also remove some key minerals from the water, so you'll have to remineralize that water. If one looks at the price of reverse osmosis filtration systems, they're not cheap. They can range anywhere from $300 to $500 or even $600 for a home unit. And many of those units will remineralize the water. So basically it takes the water, cleans out the microplastics, nanoplastics, and a bunch of other bad stuff that you don't want. And then it's going to remineralize the water so that you're getting enough minerals in your water. Now, if you look at the cost of a reverse osmosis filter, I, like you, kind of go a little wide-eyed, like, oh, that's a lot of money for water. But if one thinks about the total amount of money one spends in a given year on plastic bottled water that we consume and then, throw away essentially the bottles, or even bottled water from glass bottles. I've gotten in the habit of trying to drink water from glass bottles. And when you go out and you buy those, you feel better that you're not consuming a lot of microplastics and nanoplastics, but they are very expensive. So the costs probably line up pretty well. And when I did that analysis, I realized, well, actually the home reverse osmosis filter with remineralization actually will save on costs, provided that one is good about filling glass bottles or stainless steel bottles with that water and making sure to, when you leave the house, to take those bottles with you. Again, I don't think it's possible for everyone to avoid all consumption of water from plastic bottles. That's just not reasonable to expect, right? You don't want to be that person that's carrying around water everywhere you go, to friends' houses, at dinner, etc. I don't think we need to be that concerned about the amount of microplastic and nanoplastic in water sources. And certainly you wouldn't want to avoid drinking water from plastic bottles to the point where you dehydrate yourself or put yourself at risk. I'm not trying to create that kind of concern here. What I'm trying to say is, if you are concerned about microplastics and nanoplastics and you really want to limit your exposure, one of the best ways to do that is to limit your consumption of water from plastic bottles. And because microplastics and nanoplastics are present in tap water, you're going to need some way to remove those microplastics and nanoplastics from your tap water if you're very concerned about them. I'm not here to say everyone should do this. I'm certainly not saying that. I'm saying that if you are concerned about microplastics and nanoplastics, and we'll talk about some of the reasons one might want to be concerned about them, well, then installing a reverse osmosis filtration system on your home water might be a good idea, and it's likely to save you costs if you look at it in comparison to buying disposable bottles of water. Now, there are a lot of other ways besides drinking water from plastic bottles that microplastics and nanoplastics make their way into our system. And I can list off many of them, but I'm trying to create a hierarchy here of the things that are potentially the major sources and the ones that we can most easily avoid and that are likely to save us costs overall. So one thing that's very clear is that there's a lot of microplastics and nanoplastics in sea salt. Who would have thought? But then you think about it and it's like, well, this stuff is getting out into the ocean. There's a lot of plastic in the ocean. It's a super depressing scene when one sees the pictures of all the plastic floating out there. In fact, there's a book that I read in preparation for this episode. Gosh, it was so depressing, but important for me to read. Maybe you want to read it as well. It's quite good, although it will be a bit of a downer. The title of the book is A Poison Like No Other: How Microplastics Corrupted Our Planet and Our Bodies by Matt Simon. And I listened to this book, and gosh, it really convinces you that there's microplastics everywhere, both on land, in the air, and in the ocean, unfortunately. And of course, sea salt comes from the ocean. So a simple solution to this is, if you're going to use salt, and I'm a big fan of salt, not overdoing it, but salt has its role, right? It's a wonderful substance, both for sake of taste and for sake of health. I did an episode about salt. Again, don't overconsume salt. Don't blast your blood pressure. Don't blow a gasket. But many people would do well to have a little bit more salt, especially if you're eating a really clean diet, especially if you're hydrating very well. Focus on something like pink Himalayan salt, or salt that comes from a non-marine source. Okay? It's very simple to do. It's some of the best salt out there. It's not terribly expensive. And you would do well to avoid sea salt and get your salt from those other sources. In doing so, you're going to lower your exposure to microplastics and nanoplastics. There's some pretty scary pictures of sea salt under the microscope and all the little bits of plastic that are in there. And you only have to see those pictures once, or just hear it from me, to make the shift to Himalayan sea salt. Or in the pink salt is pretty, it looks nice, it tastes great. So that's an easy, very low cost shift that you can make. I'd like to take a quick break and acknowledge our sponsor, AG1. AG1 is a vitamin mineral probiotic drink that also includes prebiotics and adaptogens. AG1 is designed to cover all of your foundational nutritional needs, and it tastes great. Now, I've been drinking AG1 since 2012, and I started doing that at a time when my budget for supplements was really limited. In fact, I only had enough money back then to purchase one supplement, and I'm so glad that I made that supplement AG1. The reason for that is even though I strive to eat most of my foods from whole foods and minimally processed foods, it's very difficult for me to get enough fruits, vegetables, vitamins and minerals, micronutrients, and adaptogens from food alone. And I need to do that in order to ensure that I have enough energy throughout the day, I sleep well at night, and keep my immune system strong. But when I take AG1 daily, I find that all aspects of my health, my physical health, my mental health, and my performance, both cognitive and physical, are better. I know that because I've had lapses when I didn't take AG1, and I certainly felt the difference. I also notice, and this makes perfect sense given the relationship between the gut microbiome and the brain, that when I regularly take AG1, which for me means a serving in the morning or mid-morning, and again later in the afternoon or evening, that I have more mental clarity and more mental energy. If you'd like to try AG1, you can go to drinkag1.com/Huberman to claim a special offer. Right now, they're giving away 5 free travel packs and a year's supply of vitamin D3 K2. Again, that's drinkag1.com/Huberman to claim that special offer. Okay, so we've talked about bottled water sources and filtering your water. We talked about sea salt. Another major source of these microplastics that was very surprising to me is from the lining of canned soup. I don't think I'm ever going to eat canned soup again unless I absolutely need to. Sorry, canned soup companies, but there was a study. The study was entitled Canned Soup Consumption and Urinary Bisphenol-A, a randomized crossover trial. I'll describe a little bit more about what bisphenol-A is a little bit later, but bisphenol-A is a known endocrine disruptor. It mimics estrogen in ways that can activate or block estrogenic pathways. So it messes up hormone pathways, either by activating them or blocking them. It can also bind to androgen receptors, potentially, and cause some issues there. Bisphenol-A, or BPA, is not a good thing. Turns out there's lots of it in the lining of soup cans. The reason is soup tends to be a little bit fatty. So even if you get the non-fat soup, it tends to have some lipid in there, and it also has some acidity to it. And the lining helps maintain the flavor and the freshness of the soup in those cans. In this study, what they did is they gave people either fresh soup or canned soup for 5 days. Then they did a so-called 2-day washout where they took a break from soup, and then they reversed the conditions. I'll cut to the chase here because the conclusion of this study is wild. What they found was that consumption of 1 serving of canned soup daily over the course of 5 days, here I'm quoting by the way, was associated with more than 1,000% increase in urinary BPA, in bisphenol-A. Now that's urinary BPA, so people are excreting it. I want to emphasize that. But 1,000-fold increase in BPA from canned soup, I don't know. I'm not alarmist, but I only have to read this once. Think about my love of canned soup. Not that great. Done. I'm not eating canned soup again unless I'm absolutely starving and I need some soup very, very badly. My suggestion would be, unless you have a powerful reason to consume canned soup, don't consume canned soup. The one caveat being that if you can find canned soup that does not have any BPA, that is, it says no BPAs on the container, well then go at it. Have as much canned soup as you want. But I should be very clear that a lot of canned products now say no BPA, but they contain other endocrine disruptors, and the amount of microplastics and nanoplastics in those soups is still unknown. So part of my hidden motivation of this episode, and perhaps the motivation of other podcasters in the health space that are talking about microplastics now. And by the way, Dr. Rhonda Patrick did a really wonderful podcast about microplastics just recently. We didn't coordinate. That's why we both ended up doing it roughly at the same time. We talked about it afterwards and chuckled about that. I guess, we're both interested in some of the same themes, of course. One of the perhaps hidden agendas is that some of these food manufacturing companies and beverage manufacturing companies will start to include more thorough descriptions on their labeling of what is and is not contained in the various products such as canned soup and water, et cetera. Not just no BPAs, but hopefully some of the other things that are problematic that we'll talk about in a moment, such as BPS, which is another endocrine disruptor. So if you see no BPAs, sometimes there's still BPS in there. Okay, we'll talk about BPS, as well as phthalates, which are something that make plastic and other containers more durable and more flexible. And phthalates have been discussed by people like Dr. Shana Swan, who will soon be a guest on this podcast and has shown up on other podcasts, talking about how phthalates are known endocrine disruptors in development and likely in adulthood as well. So I guess my push for you to never consume canned soup again might be a little bit harsh. That's just my decision. Here's what I'll do. I'll make a bargain with the canned soup companies. If you all start putting a more thorough description about what is and is not contained in those soup cans, all right, not just no BPA, but is there truly also no BPS? Are there no phthalates, et cetera? Then maybe I'll make the move back to canned soup. And of course, most of you have probably heard that you're not supposed to microwave plastic containers. Now, you'll see microwave safe on a number of different containers. That just means that it's not going to melt in the microwave. It does not mean that you aren't being exposed to microplastics and nanoplastics and BPAs, BPS, phthalates, et cetera. So in general, it's a good idea to avoid putting any kind of plastic into the microwave, at least if you're going to microwave food and then consume that food. The other surprising, at least to me, source of BPAs and BPSs, so these endocrine disruptors and microplastics and nanoplastics, that's very robust is paper cups. Goodness gracious. I would have thought paper cups are safe. But you know those paper cups that you put hot liquids into and that often have a plastic lid? Well, even if they don't have a plastic lid on them, the lining of the paper cup, which makes those cups durable when you put hot liquids in there, like hot coffee or hot tea, well, that contains typically, unless it says no BPA and no BPS, it contains lots of BPA and BPSs, microplastics, nanoplastics. And so putting hot liquids in there, actually there was an analysis that showed that if liquid that's heated up to 100 degrees Fahrenheit is put in those containers, it starts to leach out, it starts to pull those microplastics, nanoplastics, BPAs, and BPS from the cup linings. So the other day I went across the street and bought a cup of coffee. Of course, they sold it to me in a paper cup, and I thought, oh goodness, I forgot to bring my mug, and my travel mug, my stainless steel mug or my ceramic mug. Did I not purchase the coffee? No, I'd already ordered the coffee. I didn't walk back. What I did is as soon as I got back, I took the coffee and I poured it into a ceramic mug. So I'm not extremist. I'm not somebody who's going to completely avoid these things, but in the future, I'll try and remember to bring my mug over. Some places even give you a little discount on your coffee. So again, these are cost-saving approaches. You're certainly limiting or reducing the amount of waste that you're creating in the world. So that can only be a good thing, okay? And the plastic lids, probably a good idea to avoid drinking through those plastic lids too often. Again, I want to emphasize, I'm not one of these people that's going to freak out about drinking a hot liquid through a plastic lid. These microplastics and nanoplastics are everywhere. We're consuming them all the time. We can remove them from our body. And later we'll talk about ways that you can accelerate or increase the amount of removal of them from your body. But if we're just a little bit more conscious about how they get into our body, and we're a little bit more conscious about the elevated costs and the elevated amount of trash that's going to recycle into landfill and so on, probably a good idea to just bring your mug with you, your travel mug with you. Try and make those mugs and travel mugs ceramic, stainless steel, or some other vessel that doesn't contain BPAs or BPSs. Before we move on to talk about what happens when microplastics and nanoplastics make it into, say, the testicle or the brain, like what the consequences of that is and are, I want to just briefly return to something that I flew past a while ago, and that's the analysis of microplastics and nanoplastic particles that are in bottled water. Remember, initially it was thought to be 30,000 particles per liter. Then later it was discovered using better techniques that it's actually more like 240,000 on average particles per liter. How did that huge discrepancy in data arise? Now, I realize this is not a data analysis discussion, but I want to talk about this just briefly because it illustrates for you something really important about science, which is as tools for measurement get better, so does our understanding about what's going on in our brains and bodies. And it's a very simple and kind of cool thing related to light. So you could imagine that the first paper was looking under the microscope at a drop of water taken from a bottle that was plastic and then imaged the number of little plastic particles in there. You'd say, well, there's a particle, and there's a particle, and there's a particle, and there are tools that can count those particles. Well, what if you have two particles that are really close together, right? If you recall, microplastics are anywhere from 1 micron in diameter all the way up to 5 millimeters in diameter, but nanoplastics are less than 1 micron in diameter. So how do you know that when you see a clump of stuff under the microscope in that drop of water, that you're looking at one big piece of plastic versus thousands and thousands of little pieces of nanoplastic, or even just much smaller pieces of microplastic? Well, it has to do with what's called the point spread function, and I don't really want to get into this in too much detail, but basically when you shine light on something, you get kind of a little hill of light, if you will. There's a peak at the center, and then it drops off with distance. The reason why the numbers jumped from 30,000 to 240,000 is not because the researchers got much better, it's because the tools got much better. Okay, there are new imaging techniques, and I'll put a reference to this for those of you that are into this kind of stuff, entitled Rapid Single Particle Chemical Imaging of Nanoplastics by SRS Microscopy. Okay, pretty nerdy stuff, but it's fun if you're interested in light and how light can illuminate things and show detail or not detail. But basically, what we're realizing is that there are a lot more particles of plastic in different tissues, in different things that we're ingesting, et cetera, because we're getting better and better ways of separating those clumps of light into lots of little clumps of light and realizing, oh, that looked like one particle, right? Remember, it's particles per liter. It's not one particle, it's 10,000 particles. Now you might say, okay, well, what's the difference between a bunch of little particles and one big particle? There's a big difference. What's the big difference? Little particles can make it across barriers that big particles can't. These little nanoparticles of plastic are especially concerning because those are the ones that you find in greatest abundance, or I should say, among the plastics that you find in different tissues, the ones that are in greatest abundance in the brain, the testes, and the follicle, again, these tissues that nature and evolution have gone out of their way to protect with these very stringent barriers like the blood-brain barrier, like the blood-testicular barrier, like the blood follicle barrier. Those are the ones that are getting across because they're very, very small. They can sneak through the little holes in those biological fences. They're getting deposited in those tissues, brain, testicle, and follicle, and they're staying there at least until people die, which in the case of the analysis of postmortem tissue is many, many decades later. Okay, so I'm not just raising this discussion about ways to disambiguate large particles from small particles just to be nerdy and technical. It turns out to be a really important issue with real biological implications. Okay, so lots of itty bitty little pieces of plastic getting their way into tissues like brain, follicle, testes, liver, lung, etc. What are some of the implications of this? Now, there are a lot of animal data in fish, data in mice, etc., that have explored how microplastics and nanoplastics can disrupt any number of different biological functions. But it's probably worth looking at how nanoplastic and microplastic accumulation in specific tissues is correlated with specific health detriments in humans, even though the data are correlative, right? It's much harder to get causal data from human studies because the animal studies, frankly, are hard to translate to humans. In this case in particular, because a lot of the features of animal biology, while similar to human biology, humans are animals, but you get the point, they don't correspond so easily when looking at microplastics and nanoplastics for the following reason. Let's say you have a little fish. That fish is a couple centimeters long, and it turns out there's, about an aspirin's size of microplastics and nanoplastics in that fish when that fish is analyzed post-mortem. You say, okay, well, that's kind of a lot, right? An aspirin's worth in or an aspirin size batch of microplastics and nanoplastics in that little fish. And then you look in humans and you realize, okay, well, there's more microplastics and nanoplastics, but not that much more. How much of a detriment is there really going to be? Can you look at the study in the fish, seeing, for instance, and this has been demonstrated, that you have disruption in neurological pathways, the formation of those pathways, like brain development is altered, reproductive function is altered, et cetera. It's hard to translate. We don't really know what it means in terms of humans. So we'll turn to the correlative data in humans, and I'll look to the strongest data, at least that I could find out there. And there are kind of three major cases that I think are worth highlighting. The first one is that there was a study done in humans. This was published in 2021. It was published in the Journal of Environmental Science and Technology, that found much higher levels of microplastics in the stool samples of people that were diagnosed with irritable bowel syndrome. Okay, irritable bowel syndrome is very disruptive to people's well-being. There isn't an obvious cure for irritable bowel syndrome, although some people find relief by improving their gut microbiota, by limiting body-wide and gut inflammation through any number of different things, improving sleep and eating a low-inflammation diet, et cetera. This is something that I'll probably cover in a future episode of the Huberman Lab podcast. Gastrointestinal challenges, that is. So I want to be very clear, there was no direct causation established, but it was clear that there were higher levels of microplastics found in the stool tissue coming from people who had irritable bowel syndrome than in individuals who did not have irritable bowel syndrome. And while no study is perfect, they included a number of important controls in the experiment to control for age range and some other features. So it's reasonable to assume that the accumulation of microplastics in the gut or somewhere along the GI tract had somehow led to or related to irritable bowel syndrome. Okay, now you could also imagine the reverse. This is very important to understand. You could also imagine that people who had irritable bowel syndrome perhaps are less good at filtering microplastics and nanoplastics from the food and liquids they consume than are people who don't have irritable bowel syndrome. So the causality, if it exists at all, could run in either direction or both. Nonetheless, I think it's an interesting study. And if you're somebody who suffers from gastrointestinal distress, such as irritable bowel syndrome or otherwise, I think you'd be wise. Indeed, all people would be wise, but I think you'd be especially wise to take into consideration some of the to-dos and not to-dos that I'm covering during today's episode, such as avoiding consuming water from plastic bottles, some of the stuff we talked about earlier, avoiding canned soup and other BPA, BPS containing containers and things of that sort, or things that come from those containers. The other area where there was some really interesting correlative data relates to reproductive function and hormone health. And this is where we can start to get into a bit more detail about BPAs and BPSs and phthalates and some of their roles in disrupting endocrine, that is hormone pathways. So there's a study I'll put a link to in the show note captions that's entitled Urinary Phthalate Metabolites Are Associated with Decreased Serum Testosterone, so that's in blood, in men, women, and children. Okay? This is an interesting study for a number of reasons. First of all, it emphasizes something that everybody should know, which is that testosterone plays key roles in men, women, and kids. Okay? It is not the case that testosterone is just present in men and boys. It's also present in women and girls, and it plays an important role in everybody. Okay, it's involved, of course, in some of the things that we normally associate with testosterone, such as muscle mass, bone density, strength, etc. But testosterone can be converted to estrogen. Testosterone is involved in libido in both men and women. It's involved in brain development in boys and girls, in genitalia development, and on and on. So it's an important hormone. And it was clear from this study that elevated levels of phthalates, that is, phthalate metabolites, are associated with lower testosterone levels in all those populations. They point out, quote, that the strongest and most consistent inverse relationships between level of phthalates and testosterone, that is, elevated phthalate metabolites, lower testosterone, were found among women ages 40 to 60 years. And this is very important. If you saw the episode that we did with Dr. Mary Claire Haver on perimenopause, menopause, she emphasized that perimenopause, menopause, which typically sets in somewhere between one's late 40s and 60s. Okay, there's huge variation there, sometimes as early as one's 30s. That would be early, however, more often in one's 40s and 50s, sometimes as late as 60s. Involves reductions in estrogen, but also in testosterone. And this has major implications for creating less feelings of vigor, lowered libido, less recovery from exercise, and other life stressors and things of that sort. Now, the study also interestingly shows that in, quote, adult men, the only significant or suggestive inverse association between phthalate metabolites and testosterone were observed among men 40 to 60 years old. Now, there are a number of different ways that we can interpret those data. One is that men younger than 40 have high enough levels of testosterone that, or the ranges of testosterone are great enough in that sample of younger than 40 years old, that somehow that was able to swamp out any reductions in testosterone that were caused by phthalate metabolites, or rather that once men get from 40 to 60 years old, that there's somehow a vulnerability of the testosterone pathways to phthalates, or, and none of these are mutually exclusive, of course, that the phthalates had built up in those men's system over a number of years, and then were having their major effects on those men between 40 and 60 years old. I do find it interesting that the major effects were observed in both men and women 40 to 60 years old. And the interpretation of those data that makes the most sense to me, at least, is that there's a cumulative effect of these phthalates over time that reveals itself, at least statistically, in men and women once they reach 40 to 60 years. So what are these phthalates? Well, these phthalates are things that are included in plastics that house liquids and foods that we eat or that we cook with, or that simply exist in our environment and are getting broken down and that we're inhaling and then are making their way across the blood-testes barrier, blood follicle barrier, or into any number of other tissues. Those phthalates are there, of course, to make plastic more flexible and durable, but they are known endocrine disruptors. Dr. Shana Swan has done beautiful work showing that young animals and potentially humans who are exposed to phthalates from things like pesticides in particular can actually have a fairly major disruption in what's called the anogenital distance, okay? Withhold your chuckles. The distance between the penis and the anus in people that have been exposed to phthalates, or mothers of boys that have been exposed to phthalates, those boys are born with a shorter penile to anal distance. Okay, typically it's of a certain distance, and there's a correlation with reduced anogenital distance. That is a external marker, okay? It's not that that itself is necessarily a bad thing. That's not what we're saying here, but that's an external marker that can be measured in mice, and there are some studies that are exploring that in humans as well, that correlates with a number of other things, including lower sperm counts, reduced sperm motility, and things of that sort. Likewise, BPAs, the bisphenol-A and BPS, are known endocrine disruptors. I talked about this a little bit earlier. They're known to bind to estrogen receptors, so they mimic estrogen. Sometimes they activate those estrogen receptor-dependent pathways, so they literally mimic estrogen. Sometimes they block those estrogen receptors so that estrogen cannot have the normal role of docking in those receptors and causing their normal functions. And BPA, and to some extent BPS, and potentially phthalates can dock to androgen receptors as well, sometimes referred to as testosterone receptors, androgen receptors. So the point is that BPAs, BPSs, and phthalates are not good for endocrine function, and they are present in basically all plastics unless it says no BPA or all phthalates removed. They're present in herbicides, et cetera, and they're of real concern. And it's very clear, as I mentioned earlier, that you can detect microplastics in human testes, and I didn't mention this earlier, and in semen, and it is now very clear that that's correlated with reduced sperm counts and lower sperm motility. Now, I also want to be very clear. Remember, I'm not an alarmist. I want to be clear that just because sperm counts are significantly lower in people that have a certain amount of microplastics and nanoplastics potentially in their testes or that they've been exposed to does not necessarily mean that they're infertile. It is true that total sperm count and sperm motility, forward motility being an important indicator of sperm health, are correlated with one's ability to fertilize an egg. Okay, this was covered in a quite long but quite detailed episode that I did about fertility in both males and females. There are a number of things one can do to increase sperm counts or to at least limit sperm count depletion. There are a number of things that one can do to improve sperm motility. I encourage you to check out that episode. I'll provide a link to it in the show note captions. In fact, I'll link to the specific time stamp in the show note captions that gets to those particular strategies. But the point here is that microplastics and nanoplastics are found in human testes, and that's correlated with reductions in sperm count and reductions in sperm motility. I'd like to take a quick break and thank one of our sponsors, Function. I recently became a Function member after searching for the most comprehensive approach to lab testing. While I've long been a fan of blood testing, I really wanted to find a more in-depth program for analyzing blood, urine, and saliva to get a full picture of my heart health, my hormone status, my immune system regulation, my metabolic function, my vitamin and mineral status, and other critical areas of my overall health and vitality. Function not only provides testing of over 100 biomarkers key to physical and mental health, but it also analyzes these results and provides insights from top doctors on your results. For example, in one of my first tests with Function, I learned that I had too high levels of mercury in my blood. This was totally surprising to me. I had no idea prior to taking the test. Function not only helped me detect this, but offered medical doctor-informed insights on how to best reduce those mercury levels, which included limiting my tuna consumption, because I had been eating a lot of tuna, while also making an effort to eat more leafy greens and supplementing with NAC, N-acetylcysteine, both of which can support glutathione production and detoxification and worked to reduce my mercury levels. Comprehensive lab testing like this is so important for health, and while I've been doing it for years, I've always found it to be overly complicated and expensive. I've been so impressed by Function, both at the level of ease of use, that is getting the tests done, as well as how comprehensive and how actionable the tests are, that I recently joined their advisory board, and I'm thrilled that they're sponsoring the podcast. If you'd like to try Function, go to functionhealth.com/Huberman. Function currently has a wait list of over 250,000 people, but they're offering early access to Huberman Lab listeners. Again, that's functionhealth.com/Huberman to get early access to Function. Today's episode is also brought to us by 8 Sleep. 8 Sleep makes smart mattress covers with cooling, heating, and sleep tracking capacity. Now, I've spoken many times before on this podcast about the critical need for us to get adequate amounts of quality sleep each night. That's truly the foundation of all mental health, physical health, and performance. And one of the best ways to ensure that you get a great night's sleep is to control the temperature of your sleeping environment. And that's because in order to fall and stay deeply asleep, your body temperature actually has to drop by about 1 to 3 degrees. And in order to wake up feeling refreshed and energized, your body temperature actually has to increase about 1 to 3 degrees. 8 Sleep makes it incredibly easy to control the temperature of your sleeping environment by allowing you to control the temperature of your mattress cover at the beginning, middle, and end of the night. I've been sleeping on an 8 Sleep mattress cover for nearly 4 years now, and it has completely transformed and improved the quality of my sleep. 8 Sleep has now launched their newest generation of the pod cover, the Pod 4 Ultra. The Pod 4 Ultra has improved cooling and heating capacity, higher fidelity sleep tracking technology, and even has snoring detection that will automatically lift your head a few degrees to improve your airflow and stop your snoring. If you'd like to try an 8 Sleep mattress cover, go to 8sleep.com/Huberman to save up to $350 off their Pod 4 Ultra. 8 Sleep currently ships in the USA, Canada, UK, select countries in the EU, and Australia. Again, that's 8sleep.com/Huberman. Another study that got people's attention that I think is worth mentioning, which relates to microplastics, nanoplastics, and cardiovascular disease. This was a study published in the New England Journal of Medicine in 2024, so this is a fabulously good journal. And what it found was that polyethylene, which is a component of many plastics out there, were detected in the carotid artery plaques of, in this case, 150 patients, which is approximately 58% of the ones that were included in the study. And they also found, using a technique called electron microscopy — today's fun because we get to talk about different types of microscopy. Electron microscopy allows you to look at things that are smaller than a micron. You can look all the way down into the nanometer range, right? You can start breaking up that 1/1000th of a millimeter into nanometers, and you can start to see things that are really, really small. And in this study, electron microscopy showed that there were these little jagged edge foreign particles among the plaque macrophages of these cardiovascular plaques. Okay, macrophages are part of the immune system. These are cells that go in and try and eat things up. They're kind of like little ambulances. Later, we're going to talk about microglia, which are the brain's resident macrophages, or microphages, depending on where you live and how you like to pronounce it. But the point here is that when using a technique like electron microscopy that allows you to look at really, really small stuff, it was very clear that the plaques that form these, basically occlusions within the arteries, these are not good. This is one of the reasons you want to eat properly and do cardiovascular exercise and take great care of yourself, etc. Electron microscopy made very clear that there were little plastic foreign jagged particles deposited in some of these plaques. Now, were they the cause of these plaques? Did they contribute to some of the occlusion caused by those plaques? Unclear. But it's reasonable to assume that they form part of the physical substrate that could occlude blood flow through these arteries, which of course leads to cardiovascular events, which of course are not good. So I'll put a link to this study in the show note captions. Again, these are correlative studies in humans. Correlative studies are only that, they're just correlative, but I'm trying to provide a patchwork of things that suggest that it would indeed be a good idea to try and limit your ingestion, or at least facilitate the removal of microplastics and nanoplastics from your system. Another reason to do that relates to the so-called PFASs, okay? These are a group of chemicals, sometimes referred to as the quote-unquote forever chemicals, because they are very long-standing once they get into your system. These things have names other than PFAS, which is an acronym, things like perfluoroalkyl, things like polyfluoroalkyl. I don't know how good my pronunciation of those is, but if you look up the PFASs, you'll see that these things are known to cause liver damage. They can damage the immune system. They are considered forever chemicals because they are not broken down. They last forever. Then again, some of the other components of microplastics and nanoplastics are also known to last forever. So you're starting to get a picture of these little tiny bits of plastic, some tinier than others, depositing themselves in our tissues. They're everywhere out there. They are most prominent in certain sources, but they're going to get into our system. Now, does that mean that we can't get rid of them? No. We absolutely can get rid of them. In fact, we have a number of different ways that we get rid of toxins and foreign invaders in our body. Some of those include the immune system, right? Even if you have just some sort of foreign object like a splinter, your immune system has a reaction to that. Typically, you get some pus around it, some inflammation, and that pus and inflammation is part of the process of isolating that foreign intruder, that splinter, and then eventually creating some tissues that extrude it or allow you to extrude it. You, of course, also have what's called your adaptive immune system, which doesn't just react to the presence of something foreign, but creates antibodies which can combat that, and so on and so forth. So your body has these, frankly, miraculous ways of dealing with foreign intruders of different sorts. But it does seem that microplastics and nanoplastics can deposit themselves in their tissues and stay there. Does that mean that you don't have any chance of getting them out? No. You have a liver. Your liver, yes, contains microplastics and nanoplastics, very likely if you've been alive for any amount of time, but it also has what's called phase 1 and phase 2 detoxification processes that allow you to break down and get rid of certain foreign products, including microplastics and nanoplastics. So let's talk about liver detoxification and some of the things that can facilitate liver detoxification that you actually have control over. Okay, so let's talk about liver detoxification. The liver is such a cool organ. It does so many cool things. It's not just about detoxification, by the way. It does all sorts of things related to blood clotting. It's just an amazing, amazing organ. We should probably do an entire episode about the liver and not just eating liver. I'm not a fan of eating liver. I do it every once in a while because I'm told it's nutritious. But let's talk about the living, functioning liver. There are two types of liver detoxification processes, okay? So this is not about detoxing your liver. Okay, you may hear about detoxing your liver. That's a whole other discussion that I don't want to get into, at least not here. There's type 1 and type 2 liver detoxification, okay? There's type 1, so-called phase 1 liver detoxification is also called the oxidation phase. It involves something called cytochrome P450 enzymes, okay? So enzymes are involved in the breakdown of different things. It converts toxins into less harmful components that ideally are excreted from the body. Okay. Type 2 or phase 2 liver detoxification. Again, this is not detoxification of your liver. This is detoxification by your liver. Is also called the conjugation phase of detoxification. It involves enzymes that attach molecules to toxins. Okay. It makes those toxins water soluble and easier to excrete from the body in the form of urine. Okay. It neutralizes reactive intermediates from phase 1. Okay, so phase 1 and phase 2 detoxification work together. During phase 2 of liver-controlled detoxification is where toxins are broken down and those broken down components are prepared to be removed from the body. Okay, it is thought that the liver plays a primary role in the removal of microplastics and nanoplastics, BPAs and BPSs. And by the way, I realize I didn't say this earlier and I should have. These BPAs and BPSs are sometimes chemical components within the microplastics and nanoplastics. They sometimes attach themselves to the microplastics and nanoplastics. I should have said that earlier. Forgive me. The microplastics and nanoplastics can act as what are called vectors or carriers of things like BPAs, BPSs, phthalates, and forever chemicals. Okay, I should have mentioned that earlier. So type 2, that is phase 2 of liver-controlled detoxification, is where these toxins that are in the body and potentially these microplastics themselves and nanoplastics themselves are not necessarily broken down, because some of those things can't be broken down, but where they are prepared to be excreted from the body. And we have some degree of control over phase 2 of liver-controlled detoxification. Again, I'm calling it liver-controlled detoxification so that this doesn't get misconstrued as detoxing your liver, which frankly is a very controversial topic and may not be possible at all, although simply by saying that I'm probably going to get attacked. But here we're just talking about your liver's ability to break down and remove things from your body that you frankly don't want in your body. One way that you can enhance phase 2 liver-controlled detoxification processes is by increasing your intake of something called sulforaphane, which is present in cruciferous vegetables such as broccoli and cauliflower. Now, is there enough sulforaphane in cruciferous vegetables such that you could eat reasonable amounts, that you wouldn't have to overeat cruciferous vegetables in order to get this enhancement of phase 2 liver detoxification processes? Potentially, yes. The animal studies that were carried out, so this would be in rodents like rats, used supplemented sulforaphane at dosages that were comparable to the amounts of sulforaphane that a human might ingest from a large serving of broccoli or a large serving of cauliflower. So this could be a few cups of raw broccoli or raw cauliflower, although frankly, if you're like me, that basically translates to gastrointestinal distress. I can't tell you how many times I've gone to a party and there's some broccoli and cauliflower, maybe with some dip or something like that. I usually avoid the dip because I'm not really into dips, but we'll have a few pieces of broccoli and boy, does that disrupt my gut. I don't know about you. And most things don't disrupt my gut. That's not something that I struggle with. I prefer to cook broccoli and to cook cauliflower. If you cook broccoli and cauliflower lightly, okay, so you don't just, turn into a complete mash. You don't boil it such that a lot of the nutrients are leached out into the water around it. So if you do sort of a light boil or a steam or something like that, or you pan cook it, maybe in some olive oil. This is making me hungry, by the way. You'll still maintain the sulforaphane in those cruciferous vegetables, meaning it'll still be beneficial to you. Now, some people, including me, don't tend to eat that many cruciferous vegetables. I don't know why. I just somehow don't make it a point to shop for them enough. I ought to. For people like me, or perhaps you're in the same boat, you can supplement with sulforaphane. And what you'll find is that it's sold by various companies and it's available at a quite wide range of dosages. You'll see, for instance, 2 products similarly priced. One product will contain 50 milligrams of sulforaphane. The other product will contain 225 milligrams of sulforaphane. Now, if you go to what I consider a really excellent website for thinking about and evaluating this kind of stuff, which is examine.com. I've talked a lot about this site on the podcast before. On examine.com, they talk about the translation of the rodent studies to humans. And here's what they say. They say supplementation of 0.1 to 0.5 milligrams per kilogram of sulforaphane in rats has been noted to be bioactive. Okay, just bioactive. They're not getting specifically at removal of microplastics or nanoplastics. And they translate that to a human dose of, okay, if you're a 150-pound person, then that's going to be anywhere from 1.1 to 5.5 milligrams for that 150-pound person. If you're a 200-pound person, that's approximately my weight. I think right now I'm sitting somewhere around 215, so about 100 kilograms, 215, I don't know, somewhere in there. I haven't stood on a scale in a while. It's 1.5 to 7.2 milligrams for a 200-pound person. Now, then you think about the typical dosages that are found in supplements of 50 milligrams per serving versus 225 milligrams per serving. And in either case, you realize that that's much, much higher than what's being discussed here. So what that says to me is that I would probably go with the lower dosage, although according to examine.com, they say, quote, these low quantities are likely attainable through raw broccoli or cruciferous vegetable products. So that's great. What this means is that you don't need to supplement with sulforaphane if you're willing to eat raw broccoli. They're specifically saying raw broccoli or other cruciferous vegetable products, while higher dosages may be further beneficial. So this is still a bit of a vague space. I realize there's some discrepancies in what I'm describing here. I said you could lightly cook the broccoli or cauliflower. That's my read and understanding of sulforaphane, that it's not broken down at low temperatures. But perhaps you just decide to eat it raw if you can bear it. I can't, so I don't. You could supplement it if you choose. What dosage? Well, that depends on your weight. And it seems that in any case, most supplements are going to more than cover the amount of sulforaphane that's described here, translated from the rat studies. So in my case, after researching this episode, I opted to start taking 50 milligrams, 50 milligrams of sulforaphane per day. I'm going to see how that goes. I guess it's fair to say that I'm sufficiently concerned about microplastics and nanoplastics, given that I'm 49 years old. All my biomarkers seem fine, but hey, I'm always interested in doing something for my health, or to promote my health, that is, if I can. And it's pretty clear to me that if one's thinking about liver-controlled detoxification, both for sake of offsetting or removing BPAs, BPSs, but also other potentially toxic metabolites from microplastics, nanoplastics, and other environmental factors, that taking 50 milligrams of sulforaphane per day perhaps can be beneficial. So I don't think it's necessary for everybody. In fact, I think everybody should probably be getting some cruciferous vegetables in their diet anyway, at least once a week or a couple times a week. So if you're not interested in supplementing, that would be the route to go. If you are interested in supplementing, I'll provide a link to this particular location in the examine.com page so that you can translate some of these dosages to your potential sources of supplemental forms of sulforaphane. The other way that microplastics and nanoplastics can be excreted from the body is in the bowel. And one way to potentially increase the amount of microplastics and nanoplastics, BPAs, BPSs, phthalates, and forever chemicals, those PFASs, from your body, is to make sure that you're getting enough dietary fiber. Now, most people can do that simply by eating a fair amount of fruits and vegetables, which I always make a point to do. I also ingest starches. Okay, so I'm not pure carnivore. Things like rice, like oatmeal. I like fresh pastas, although it's mainly rice and oatmeal for me these days in terms of starches. Plenty of fruits and vegetables. That's something that I just really make it a point to do. Why is fiber good at doing this? Well, it can bind lipophilic molecules. Okay, it can bind molecules that are able to cross cell membranes. And earlier we were talking about the fact that BPA and BPSs mimic estrogen and combined estrogen receptors and potentially to androgen receptors as well. Keep in mind that one of the reasons why those so-called steroid hormone pathways, I know people hear the word steroid and they think performance-enhancing steroids, but no, it turns out that testosterone and estrogen are both steroid hormones. One of the reasons those are interesting is that because of their structure, they're able to bind cell surface receptors and have effects on those cells. They are also able to pass through, the hormones, here I'm not talking about BPAs and BPSs, but the hormones, testosterone and estrogen, can actually get to the nucleus of cells and can control gene expression. These steroid hormones, testosterone and estrogen, work in a very coordinated fashion to create what we call secondary sex characteristics, which are the characteristics of the external body and brain changes and internal changes all over the place, right? Ovaries, testes, etc., that are what underlie what we call puberty. And that's because these molecules can actually control gene expression. So when we talk about these molecules like BPAs and BPSs impacting these pathways like estrogen and androgen pathways, this is serious stuff because what you're doing is you're potentially activating or blocking pathways that are involved not just in the function of those cells, but actually the genes that those particular cells express. And this is particularly concerning for any kind of hormone-dependent cancers, right? It's perhaps not surprising to you based on what you now know about how hormones work with gene expression, et cetera, that many tissues that turn over cells a lot, such as the testes, right, producing sperm pretty much throughout the lifespan, the follicle and eggs, right, breast tissue, right, these are common sites of cancer. There are other cancers that can form, of course, in other tissues like the pancreas and brain, et cetera, but tissues that turn over quite a bit because of the involvement of the cell cycle and because cancer is, among other things, a dysregulation of the cell cycle and an overproduction of cells that we call tumors. Those are pathways that are particularly vulnerable to endocrine or hormone disruption. And this is why there's additional concern about microplastics and nanoplastics, perhaps increasing cancer rates, in particular in tissues like the ovary, in particular the testes, in particular any tissue where there's a lot of cellular turnover. So the point here is that eating broccoli, eating cauliflower, potentially supplementing with sulforaphane. Here I'm summarizing a bit what I talked about earlier. Avoiding drinking water from plastic bottles, maybe getting a reverse osmosis filter, avoiding those diabolical canned soups. I had no idea about these canned soups. Or ensuring that the canned soups that you're eating are safe in the ways that we discussed earlier. Avoiding sea salts. I'm throwing a few other things in here that I haven't mentioned yet, avoiding non-stick pans, trying to cook mainly with cast iron or ceramic and making sure that those are BPA, BPS, and PFAS free. Just look at the packaging, do a little bit of homework there. And get this one. This is a really surprising one, or at least was surprising to me. Carbonated water, mineral waters. A few years ago, there was an analysis of different popular forms of carbonated water, which is sold in glass containers, It turned out that Topo Chico, which I past tense, happened to love. Topo Chico had 9.76 particles per trillion of these PFASs, these forever chemicals, That was an analysis done in 2020. Perrier, 1.1. San Pellegrino, 0.31. So we're comparing 9.76 versus 1.1 versus 0.31, which tells me I'm avoiding Topo Chico. I might even avoid Perrier. I'll probably drink San Pellegrino. I'll probably buy a Perrier and drink a Perrier every once in a while. I'm not crazy about carbonated water. By the way, this was an analysis by Consumer Reports, and it caught some attention such that the Coca-Cola company, which makes Topo Chico, said that they were going to fix this problem. And they claimed, I don't know if they've done this, all right? I don't want to get the folks at Coca-Cola angry with me. Coca-Cola claimed that by 2023, they were going to cut the amount of these particles in half, but that would still make them 4.5 parts per trillion, still much higher, at least 4 times higher than any of the other brands. So I have to be direct. I'm just speaking from my own experience and choices. Until I see data that Topo Chico has reduced the amount of these foreign contaminants to basically less than 0.31, I'm going with San Pellegrino or Perrier. I don't tend to drink a lot of mineral water, but given that you're ordering it in the glass in a glass container, that is, given that these things are not particularly cheap, right? And that you have choices. You could either decide to avoid carbonated water altogether, or if you're going to be smart about it, you probably want to avoid the ones that contain more of these foreign contaminants because of their ability to get lodged in different tissues in your body. So that was very surprising to me that you would have these forever chemicals in carbonated water. What it tells us is that the water going into those products contains either microplastics, nanoplastics, PFAS from other sources or something. And so I think that we should all be aware of this. If you're going to drink carbonated water, probably going with a Perrier or San Pellegrino would be better than going with Topo Chico, because even though they've halved the amount of these forever chemicals in there, it's still quite high. Okay, so I've mentioned some to-dos to reduce your microplastic, nanoplastic, BPA, BPS, and PFAS exposure, such as ingesting cruciferous vegetables, potentially supplementing with sulforaphane, trying to avoid drinking out of plastic water bottles. There are a few other things I'll just list off here to keep it relatively short. I talked about making sure you're getting enough dietary fiber. I talked before about using a glass or steel vessel and reverse osmosis water, using Himalayan salt, avoiding sea salt. The other thing that you can do, and I mentioned using cast iron and ceramic as opposed to nonstick cookware whenever you can. And if you're going to microwave food, making sure that you're doing that on plates or in containers that does not or do not contain plastic of any kind, even if it says microwave safe. The other thing is to sweat, okay? We vastly underestimate or downgrade the power of sweating. Sweating is an incredible mechanism. Now, I realize that as soon as somebody says sweating is a great way to remove toxins from the body, that a bunch of people out there get really inflamed, pun intended. I'm not saying that. What I am saying is that there are a number of different ways for foreign products to leave the body, including urine, feces, but including sweat. Okay, so I'm not saying that's going to detox you completely. That's not what I'm saying. Okay, I don't fall into that camp. However, there are a number of beneficial aspects to sweating. And also there are a number of beneficial aspects to doing the things that make you sweat. So I've done entire episodes about deliberate heat exposure. So things like sauna, done anywhere from once a week to 4 times a week. Pretty impressive data in terms of reducing all-cause mortality, improving cardiovascular function. It's also for most people pretty pleasant to sit in a sauna. If you don't have access to a sauna, taking a hot bath, not so hot that you burn yourself, but a hot bath, that also will activate some of these same pathways. Things like hot yoga, things like going out for a run in a hoodie, trying to get your body to sweat pretty robustly at least once a week is a good idea for all sorts of reasons. Also just your ability to thermoregulate. By the way, for those of you that don't sweat much, sweating is actually something that you can get better at. That's right. You can get better at sweating by what? By sweating, by exposing yourself in safe ways to heat. And I talk about that in the deliberate heat exposure episode. We also have a newsletter on deliberate heat exposure. I'll put links to those in the show note captions. And those explain safe ways to encourage sweating. Why am I talking about this? Well, sweating may help remove some of the things that are attached to microplastics and nanoplastics that can act as endocrine disruptors. It's very, very unlikely that the microplastics and nanoplastics would actually be removed as whole particles in sweat. I think that's very unlikely, frankly. What's more likely is that the microplastics and nanoplastics aren't really getting removed from or broken down within our body at all. They're getting lodged into these different tissues, but the stuff that's on them and in them is potentially causing some of the biological harms that we've talked about. And so removing those more robustly is what sweating is about. It's what consuming cruciferous vegetables is about, and so on and so forth. So those are a few more to-dos. The other to-don'ts, or I should say don'ts, are things like avoiding consumption of packaged food or food that's packaged in plastic. Now, this is tough to do. You know, I love berries, for instance. I love blueberries. I'm what you call a drive-by blueberry eater. If there's blueberries in a bowl, I just kind of like sweep them up like by the fistful. So if there are blueberries on the counter, you're probably not getting very many. I'm getting most of them. I love blueberries, but I noticed that I was starting to accumulate, and of course I recycle those blueberry containers that are those plastic containers. One way that you can avoid plastic packaging is go to farmers markets, bring your own bags, bring your own baskets. I love that at the farmers markets, they have those cardboard containers. Of course, some of you may be shouting, wait, but those are colored green and the coloration is a problem and they have the microfibers with the, yeah, true, but probably better than plastic containers that they use now in the grocery store for pretty much every fruit and vegetable. Okay, so the solution is either farmers markets or trying to bring your own bags to the grocery store. I know this is starting to sound kind of hippy dippy, but these little things make a big difference over time. You're reducing your plastic waste. You're reducing the amount of plastic exposure of the fruits and vegetables you eat. This can correspond to a real difference in the number of microplastics and nanoplastics and the bad stuff that comes with them that you ingest. And again, most of the time, these things are going to save you cost as opposed to introduce new costs. The other don'ts that we haven't talked so much about are to reduce the number of clothes that you purchase. I know this might seem like, oh my God, where's this all going? But it turns out that one of the major sources of microplastics and nanoplastics are the microfibers on clothing that come off in washing machines that then get distributed into the oceans through the water or that escape into the air. There are a number of ways that you can trap those. There are the things like the guppy bag that you can, I love the name, the guppy bag that you can buy at pretty low cost. You can find those easily online that will trap some of that stuff. There are filters that you can put within specific washing machines. Some places actually require this now that capture those microfibers. These microfibers, when I first heard about them, I thought, oh goodness, we're really talking about microfibers in clothing? Well, wear 100% cotton clothing. But then you find out, because I read this book, this scary book, and it is scary. It does kind of bum you out when you start reading this stuff, that when you read A Poison Like No Other, How Microplastics Corrupted Our Planet and Our Bodies, you find out that so much of the waste that exists in landfills is clothing that people have discarded, and there was nothing wrong with that clothing. The clothing has dyes, it has little microfibers, the stuff gets into the environment, gets into the oceans. Here's the simple solution to all this. It turns out that we replace far more clothing than we need to. Okay, this is actually a great relief to me because I love few things more in terms of clothing anyway. The feeling of a t-shirt that I've worn many, many times and it's really, really soft and kind of worn down. That kind of distressed look t-shirt, even though that might be fashionable to some people it's not. I love the feeling of a really worn down, soft t-shirt, even the ones that have a little bit of, jagged toothing along the collar. Now, some people might loathe that. They only want the pristine t-shirt that, is super crisp. That's not me. I know I own a few of these black button-down shirts, and indeed, the same ones. I use them over and over again. I do own a fair number of them, but I use the same ones over and over again. And I think that's in keeping with this other recommendation, which this book, A Poison Like No Other, said could make a major dent in the amount of microplastics and nanoplastics that are out there in the environment and that we end up ingesting, and that the other animals on the planet who are so very important end up ingesting and potentially suffering from. And that's to simply not buy or replace so much of our clothing, but to reuse our clothing. Now, the argument has been made, and they counter it in the book, well, then you're just going to wash the same clothing over and over. You're going to break down those microfibers and introduce those dyes and things into the ocean, et cetera, into the air. But it turns out that when you reuse the same clothing and wash it over and over again, you actually see a diminishment in the amount of microfibers and the amount of dyes and things that you extract from those clothing over time. Okay, so now in some odd way, we're talking about clothing purchases or non-purchases in this case on the Huberman Lab podcast. But, in researching this episode, I discovered that these are a major source, if not the major source of microplastic and nanoplastic particles in the environment and landfills, ocean, air, et cetera. So while I believe none of us are going to go out there and create a tire that doesn't degrade as quickly as current tires, right? Most of us don't have the capacity to do that. Let's face it, we got to get around in vehicles. All those tires breaking down, not a whole lot we can do about that. We're inhaling all that stuff. But we can make the decision to use the clothing that we've got for longer periods of time. Is it really necessary to keep buying more and more clothes and replacing the old clothes? Throwing out the old clothes or even donating those old clothes. Who knows? I'm all for donating clothing after you're done with it, but now I have justification for just keeping the t-shirts that I have, making them softer and softer and softer over time. And I should mention that, of course, when you wear clothing that is shedding these microfiber particles, you're ingesting, or rather you're inhaling more typically, the microfibers and the microplastics and the nanoplastics and all the bad goodies that go with them. As I say that, I think we need to be fair about what that means and what it doesn't mean. I personally just don't see myself going around and looking at labels, finding only 100% cotton with no microfiber shedding, no dyes, et cetera. I mean, there are a lot of things that are now introduced to even 100% cotton clothing that make them a little bit more water and stain resistant. It's very, very difficult to find such sources of clothing, right? I know they're out there, but they're very difficult to find, and they're quite costly in many cases. If you happen to know of some true low-cost versions of those things, please put those in the comment section on YouTube. But I think we have to be realistic here. Plastics were introduced in the 1950s. They are everywhere. They are in our clothing. They are in tires. They are in medical devices. They're just everywhere. The point of this discussion today is not to try and eliminate plastics. I don't think that's reasonable. I don't even think that would be useful relative to the incredibly powerful use of plastics in just about every industry. There's always a trade-off with these sorts of things, and I acknowledge that. What I'm talking about is trying to limit your exposure and trying to buffer yourself against this bioaccumulation in ways that can protect your endocrine system, protect your brain, protect your cardiovascular system, protect your liver, protect the organs and tissue systems of your body so that you can thrive as much as possible. So there are some other not to-dos or things to avoid. Microwave popcorn turns out to be a major source of these things. Basically, any bag or container, can, bag, or plastic that has a lining that prevents oily stuff from staining it and getting through, such as microwave popcorn, very likely is a source, or I should say a rich source of microplastics, nanoplastics, and endocrine disruptors. Does that mean that if you have some microwave popcorn every once in a while, that's going to screw up your estrogen or testosterone system and make you infertile? No, I don't believe that. These things are all a matter of dosage, exposure over time, and so on. Toothpaste and plastic tubing, another rich source of microplastics, nanoplastics that people ingest, of course, because you're putting it in your mouth. When I did the oral health episode, I talked about some tooth tablets. I've become quite fond of these. I have no financial relationship to the company that makes these, but these are tooth tablets that include something called hydroxyapatite, which is great for the remineralization of teeth, because it turns out your teeth can fill in little cavities that start to form, and overall tooth health. It's also great for travel because, first of all, these things come in a glass jar, so no plastic. You take the tooth tablets and you just chew them up and then you brush your teeth. It's great because you don't have to worry about how many ounces is going through the screening process at the airport, because it's not a liquid, it's not a paste, it's a tablet. They're super convenient. I love those. We'll provide a link to those in the show note captions, even though I have no relationship to the company. I'm just a big fan of that sort of thing, the convenience and the fact that it's housed in glass. But as I say all this stuff, right? Avoiding drinking out of plastic. Don't turn over your clothing so much. Wash your clothes, but don't purchase and throw away clothing too much or more than is necessary. Avoiding sea salt, these kinds of things. These are all just choices for you in the buffet of options of ways to reduce your microplastic, nanoplastic ingestion and exposure, and the bioaccumulation of those things over time, and to increase, in the case of things like sulforaphane and sweating, et cetera, and to increase the detoxification and removal of some of the more harmful products attached to or within these microplastics and nanoplastics, right? I certainly don't expect anyone, including myself, to start living a life free of microplastics and nanoplastics. To do that, you'd probably have to leave planet Earth. I know certain people are developing plans to enable us to do that, even if we're not astronauts. And frankly, when you get out to Mars or you get it into outer space, those microplastics and nanoplastics, based on everything I've learned and how incredibly sneaky, small, and pervasive they are, well, they're probably in outer space as well. Now, the final thing I want to touch on is the potential role of microplastics, nanoplastics, BPAs, BPSs, and forever chemicals on the developing brain. And this is an area that I'm very familiar with because much of my career I've focused on brain development, neural development. And one can find a lot of papers out there about the potential neurotoxicity of micro and nanoplastics. Certainly the established neurotoxicity of microplastics and nanoplastics in animal models, and the potential neurotoxicity of those things in human tissues. Now, of course, because this animal literature and some correlative human literature have been out there for a while, the media and some people in particular have become concerned about and have mentioned the potential role of microplastics, nanoplastics, and the bad goodies that attach to them or come from them in potentially causing neurodevelopmental disorders such as autism and ADHD. I want to be very clear. I went into this literature. I read this review. It's a quite nice review. The Plastic Brain Neurotoxicity of Micro and Nanoplastics. And sure, there's a lot of animal literature showing, for instance, that there's a disruption in certain enzymatic pathways within neurons. In particular, and this is the one that intrigues me the most, a disruption in what's called acetylcholine esterase. Acetylcholine is a neuromodulator involved in neuroplasticity, in attention, among other things, levels of alertness, a number of things, including control of the so-called neuromuscular junctions that allow for us to move our limbs. Acetylcholine esterase is involved in the degradation, the breakdown of acetylcholine in the synapse. So neurons release acetylcholine into the synapse where it can have an effect on muscle or it can have an effect on other neurons if we're talking about within the brain. And indeed, there's a fair amount of evidence showing that microplastics and nanoplastics are correlated with reductions in or just changes in acetylcholine esterase activity. Now, it is true that where acetylcholine is released in the brain, it can impinge on dopamine circuits that are involved in reward pathways and movement. But I want to be clear. People have taken some of those findings, translated them to the correlative data in humans, and have started to link the presence of microplastics and nanoplastics, in their words, not mine, in their words, to neurodevelopmental disorders such as autism and ADHD. And while there is some evidence that some of the behavioral components or cognitive components of autism and ADHD may increase in line with increases in microplastic or nanoplastic exposure, the data there are still, in my opinion, very, very weak. So in my opinion, it's far too early to conclude that microplastics and nanoplastics have any role, and certainly not a causal role, in the development of autism or ADHD or other neurodevelopmental disorders. That said, the presence of microplastics and nanoplastics in placenta and in that first stool from babies, which shows us that those microplastics and nanoplastics are getting into the developing fetus, well, that does, I think, raise level of concern. And it certainly should motivate pregnant women as well as people who have newborn kids or are going to have kids to look around their home environment, think about the things they're putting into their body or the vessels they're using to ingest liquids, to ingest foods, and to start limiting microplastic and nanoplastic exposure, certainly during, but also perhaps before pregnancy and after pregnancy when one is breastfeeding. So the point here is that we can't draw a direct relationship between microplastics and nanoplastics and neurodevelopmental disorders. I don't think it would be appropriate at all to do that. However, given that microplastics and nanoplastics have these issues, both from their own breakdown, their presence, right? Their own structural presence can be a problem. The chemicals within them can be a problem. The chemicals that attach to them can be a problem potentially. I think learning to limit our exposure throughout our lifespan, learning to reduce the bioaccumulation through detoxification and excretion pathways using the various approaches that we talked about, and certainly to pay extra attention to those things around the time of, meaning before, during, and after pregnancy, is especially important because we just don't know all the things that these chemicals and these plastics are doing, but none of them seem to be very good, at least not in terms of the ways that they impact our brain and bodily tissues. Okay, so today we've talked a lot about microplastics, what they are, where they're found, how they get into our body, where they get lodged within our body, what they potentially do in our body, none of which is good. Some might be innocuous, some might be bad. None of which, at least as far as I know, is good. And some ways, both through some to-dos and some to-avoids, that we can increase our excretion or our breakdown and removal of the bad stuff on and in microplastics and nanoplastics. And I realized that even though we covered a lot of things, we also just scratched the surface. For instance, we know that receipts are rich sources of BPAs. Okay, so if you are somebody who handles receipts a lot for your job, probably best to use nitrile gloves, okay? Not latex gloves, but nitrile gloves. Those are going to protect your hands. If you're somebody who purchases things, maybe just say, no thanks, I'll take the electronic receipt or no receipt. Okay, however, we need to be reasonable here as well. Does this mean that if you touch a receipt that you're going to screw up your testosterone or estrogen? No. But you probably don't want to be rubbing those receipts. And it's very clear that if you use sunscreen or lotions of any kind on your hands, you handle receipts, it can increase the access of those BPAs to your bloodstream. And if you're somebody who handles receipts a lot, well then probably best to use those nitrile gloves. The point here is that there are a lot of different sources of these BPAs, BPSs, PFAS, so-called forever chemicals, microplastics, nanoplastics. I also would just encourage you to do your research. Look at the cans. that you drink from. Ensure that they don't include BPAs. Look at the different things that you cook with in your kitchen. Try and cook from cast iron or ceramic. And if you don't, look at the other pans and cans and things in your environment and see what your likely exposure to these BPAs, BPSs, and forever chemicals is, and make choices accordingly. That's what today's episode and frankly this podcast is about. It's about you being informed and making the best choices for your mental health and physical health. If you're learning from and or enjoying this podcast, please subscribe to our YouTube channel. That's a terrific zero-cost way to support us. In addition, please subscribe to the podcast on both Spotify and Apple. And on both Spotify and Apple, you can leave us up to a 5-star review. Please check out the sponsors mentioned at the beginning and throughout today's episode. That's the best way to support this podcast. If you have questions for me or comments about the podcast or guests or topics that you'd like me to consider for the Huberman Lab podcast, please put those in the comment section on YouTube. I do read all the comments. For those of you that haven't heard, I have a new book coming out. It's my very first book. It's entitled Protocols, an Operating Manual for the Human Body. This is a book that I've been working on for more than 5 years, and that's based on more than 30 years of research and experience. And it covers protocols for everything from sleep to exercise to stress control, protocols related to focus and motivation. And of course, I provide the scientific substantiation for the protocols that are included. The book is now available by pre-sale at protocolsbook.com. There you can find links to various vendors. You can pick the one that you like best. Again, the book is called Protocols, an Operating Manual for the Human Body. If you're not already following me on social media, I am Huberman Lab on all social media platforms. So that's Instagram, X, formerly known as Twitter, Threads, Facebook, and LinkedIn. And on all those platforms, I discuss science and science-related tools, some of which overlaps with the content of the Huberman Lab podcast, but much of which is distinct from the content on the Huberman Lab podcast. Again, that's Huberman Lab on all social media channels. If you haven't already subscribed to our Neural Network newsletter, our Neural Network newsletter is a zero-cost monthly newsletter that includes podcast summaries as well as protocols in the form of brief 1 to 3 page PDFs. Those protocol PDFs are on things like neuroplasticity and learning, optimizing dopamine, improving your sleep, deliberate cold exposure, deliberate heat exposure. We have a foundational fitness protocol that describes a template routine that includes cardiovascular training and resistance training with sets and reps, all backed by science, and all of which, again, is completely zero cost. To subscribe, simply go to hubermanlab.com, go to the menu tab up in the upper right corner, scroll down to newsletter, and provide your email. And I should emphasize that we do not share your email with anybody. Thank you once again for joining me for today's discussion all about microplastics and nanoplastics. And last, but certainly not least, thank you for your interest in science.